So, gentlemen and ladies, welcome back. I want to tie up some loose ends here, things we've covered. I'm using Friday as sort of a day to catch up on here. There was some things that some classes maybe didn't get to on some of these things. I want you to go. I don't think there's any notes I didn't get to in 9.2, but maybe I didn't. So I'm going to jump in here. That's the vocab we talked about. More vocab, proving the theorem works. I don't know that all three classes got through this. You have to check their answers on these. So I'm going to try to throw this up here. Just give you a second to check these. This is the pentagon and the hexagon. You can pause this if you want to work on it. If you didn't get a chance to work on it. I did change this number for one of the classes. So if you are in third period, this number was 10. And it's a little different set of answers on here. All these numbers are going to be smaller. If you're in fifth period and you're absent, or you're in eighth period, seventh, eighth period, this is what the work should look like. I just wanted to throw that up here and give you a chance to check that. The other thing I want to show you is give you a chance to check your work. If you check the odds in the back of the book last night, you did a good job. Here's what the even should look like. So I just want to give you a chance to look those over so you don't go into the weekend not knowing whether you did it right or wrong. Because some of the homework this weekend is going to involve finding area of regular polygons. I want to make sure you sort of have a chance to troubleshoot those. So those are the answers. If you need to pause those, take a little closer look at them. We certainly should do that. I'm going to continue on to another part of something I didn't finish on the previous section for any of the classes. No one got through all of 9.1b, so I'm going to jump down to that real quick. You got to this word problem, most of the classes. So I'm going to skip that for a moment. This is the one you didn't have a chance to do a couple days ago, was the Santa problem. Oh, you know what? There's two problems, a Santa problem and another one here, so we'll get both of them here. So take a minute to try this one here. Santa's got 40 meters of fence that he's trying to figure out what to build a reindeer pen with here, and he wants to maximize the dimensions for his pen. He doesn't like decimals. He wants to use integer values for all of these. And it says give 4 possible areas he could create with this amount of fence. This is 9.1a. Very last problem on the notes we did for 9.1a. So it was right after this word problem that we talked about in all the classes. So there it is. So, he's trying to build a rectangular pen, keyword on there, because it has to be rectangular. So I'm just going to throw on one possible choice you could have. A long, narrow pen that's only 2 meters wide, which is about 6 feet. And think about it, if this was 2 meters, how long would the other dimension have to be? Well, if that's 2, this would have to be 2. Now he's got 36 meters of fence left over, which means the other dimension would be 18. And all these is assuming are rectangular sections here, rectangular pens. So that you could have a whole bunch of different choices on here. He likes integers. You could have 2 and 18. That might not give you a lot of space. That's only 36 square meters of space. Rudolph and a gang might go on strike and say it's not enough room for them. It's uncomfortable. They have to rub against each other and they want more space. So you might go with a little bigger space on there. Maybe you choose 6 for a dimension of the height. And if the thickness is 6, the width would have to be 14. Obviously, the perimeter has to add up to 14. I'm basically giving you a perimeter here when I say a distance of fence. You can do whatever you want with it. 6 times 14 gives you an area of 84 square meters. That's a little better. Rudolph and Blitzen and all those guys might be a little bit happier with that. The idea, we're eventually trying to get to a situation where we maximize the space possible for the reindeer. So 6 by 14 didn't quite do it. Maybe we'll give another foot going this way. 7 by 13 might do a little better. 7 by 13 I think is 91 square meters. Yeah, that's a little better. We're increasing each time. And of course, you get to this maximum space is a type of rectangle, a very special type of rectangle called a square. The most space you could possibly get, most rectangular space you could possibly get would be 100 square meters on there. Pretty simple. Hopefully that makes sense. You could have different, you certainly shouldn't have different numbers than these because you got different combinations you could have. You could go 8 and 12, as another possible combination on there. So, I want to just talk about sort of the design situation where you got some choices to make. The other thing, I can keep it going here. The other thing I want to jump to is the very last problem on very last problem on the page. And I wasn't here to do this last week, so take the opportunity to kind of give you a chance to change the last problem on 9.1b. section 9.1, problem, the second page of that. And I had to change some things around because I wanted to reword this problem from what I had last year. Cross out where it says find the other base, cross that out. I'm going to give you the other base here. So the area is 50 square meters, or square inches, sorry. The height is x for the trapezoid. One of the bases is x plus 2, and you'll have to add this on. This is not on your paper. There's not a spot for it. I'm modifying the problem. The other base is x plus 8 inches. So I've got that in red on here to try to remind you to add that on there. And just cross this off. Find the other base. Well, I'm giving the other base. It's x plus 8. The question is find the length of the missing midsegment. And don't find it in terms of x. Go a little further and find the value of x. So you might sketch a trapezoid on there. Take these dimensions and apply them there. You can obviously add the height on there. I suggest you pause this and take a minute or two and get after it and see how far you can get. The height is x. The longer base is pretty clearly x plus 8. The shorter base is pretty clearly x plus 2. And this ends up being a very nice problem on here. You remember to look back in the top of your page for the area of a trapezoid. Area of a trapezoid is the average of the bases times the height. So you'd add these two together and then divide that by 2 and multiply that by the height. So x plus 8 plus x plus 2, multiply that by x, and cut it in half. Of course, the area was given. You're going to plug in 50 for the area and solve that equation. Hopefully you can see right away, when you multiply x times 2x, you're going to get a quadratic. This is a factoring related problem on here. And the fraction, you can do a lot with that. You can decide how you want to deal with that. Some people will distribute that and take half of 2 and half of 10. Some people might clear it and multiply this side by 2 and get 100 on that side. I think at some point you're going to want to divide the whole equation by 2 if you end up multiplying by 2. So that's probably not a good idea. If you distribute, it goes away. You get x plus 5, which isn't too bad. I already distributed the other way, actually. Distributed this way, and then distribute the 1/2. You should eventually, and like I said, there's a bunch of different ways to get there, eventually get to that equation. You could distribute here and get x squared, distribute here and get 5x, and then bring the 50 over if you want. And like I said, it ends up being a factoring problem. Factors of 50, of course, are 10 and 5. 10 should be positive, the 5 should be negative. And you evaluate which of these two roots is going to work, negative 10 or positive 5. And if you think of this as a height, this would never work here. It wouldn't work on any of them. So the 5 is the only one that works. Take the 5 and plug it back in here. You get 13. Take the 5, plug it back in here, you get 7. So those are your two bases. Reread the question. The question asks you to find the midsegment. The average of those two, of course, is 10. So hopefully that ties up some loose ends for you. All the notes should be completed on there. The people in 5th period, I'm going to go back, 5th and 6th period. You guys never got through all these examples. So I'm going to go back in a part 4 and add that on there for you guys on a second YouTube video. You certainly have class to get caught up on that, to be totally caught up with the other classes.